good morning or good afternoon, depending from where you are joining us. Most people in Europe, but we also have a significant number of people from the US. I'm very excited about this webinar where you will mostly hear two people speaking. Okay, on the right-hand side is me. My name is Stefano Cucco. I work with Solarplaza as a senior project manager. And our speaker of today will be Mr. Gerhard Mutter. You will hear him in some minutes after I've done a brief introduction. Very short on Solarplaza. Most of the people listening got to this webinar and probably know us therefore already. About Solarplaza, we are established in 2004. Our main business is organizing conferences and trade missions around the world. So far, in more than 20 countries. We have a huge own network, and yeah, if you're looking to explore new markets or dive deeper into certain topics, check out the events we are working on. They could be very beneficial. A couple of these events, just to highlight them in half a minute. On the right-hand side, you see the Solar Finance Tour in India, which will take place in, I think, less than 2 weeks already. Also coming up soon, of course. Also coming up soon, of course, is our Renewable Energy Crowdfunding Conference on the 5th of November in London. Very interesting event, our solar PV trade mission in Central America and Colombia, scheduled towards the end of November. YieldCon, the Renewable Energy YieldCo Conference on the 3rd of December in New York, and of course Solar Asset Management Europe, which will take place in 3 weeks in Milano in Italy. And this webinar is also a prequel to this event, of course. A little bit on Solar Asset Management Europe. Some people of you will already know it's the leading conference in Europe on topics that relate to the operational phase of PV assets and portfolios. It's a 2-day conference with over 40 speakers, 300 participants, and this year we are on 30 sponsors and 20 exhibitors of them. Really looking forward to it, and it's going to be a great and insightful event again in 3 weeks. Here you see a selection of the companies that will be attending the event. You can also find this on the conference website, of course. If you're listening to this webinar either now or later this week, you can benefit from a special discount code on your registration in case you plan to attend the event. So write it down or check back later. The speaker of today, I already introduced him, is Mr. Gerhard Mutter. He is Technical Director at Alternative Energy Solutions. He and his team overview a portfolio of PV parks. By August, this was still more than 700 megawatt in capacity, so an impressive portfolio, and Gerhard will tell us more about this. I really look forward to this specific webinar because I think the insights he will share with us are of particular interest not only for service providers but also monitoring and data companies, owners and investors, and will definitely hopefully help you further to professionalize and optimize things in your business. Gerhard will share best practices in bringing down losses significantly and optimizing performance in this portfolio. He will explain the situation, the issues they have been facing the last 3 years, but also findings and some things towards the end of the presentation. For instance, the effect of forgotten grass cutting, the washing effect of rain, and also the impact of stopping O&M after a couple of months. And what makes this very interesting is Gerhard will not only talk about the technical implications, but also the financial impact based on certain feed-in tariffs. Before we start, I'd like to know who is in the audience. So also our goal of this webinar is to make it a bit interactive. So on one hand, we will share the opportunity to ask questions through the panel on the right-hand side. Feel free to write your questions, and me or my colleagues can ask them to Gerhard during this webinar or at the end, depending on how things flow. Also, if you have any issues, just write it on the right-hand side. But first, I'll ask my colleague to go live with the poll, which is currently the case. And let's give you guys a few seconds to yeah, share with us what your background is. It's always interesting to see. Okay, well, let's see. I'm asking my colleague to put up the results if we can. Let's see if that's working. I think at the moment we should be able to see the breakdown of people. It's quite an interesting mix and quite balanced, I would see, although the data monitoring people are a bit with more people here, which makes sense given the topic of the webinar. But I'm happy to see that the interest in this topic is well distributed. Good, let's continue to the presentation of Gerhard. As I mentioned, any questions for Gerhard or for my team, just write them on the right-hand side, and I'll try either during the webinar or towards the end to ask your questions to Gerhard so that we can have the interaction there. Let's see if we can make Gerhard presenter right now. Oh, yes, let's do it now. Looking at my colleague, so we can unmute Gerhard and make you presenter. Gerhard, are you with us?
I'm with you. Hello, everyone. Thanks for introducing me. Can you see my first slide?
Yes, we can hear you well, and we can see your screen. So go ahead, and we look forward to your presentation.
Thanks. Okay, I want to talk to you about performance improvement achieved by advanced data analysis, and want to show you this in 4 major steps. First is a bit background. Stefano already started, and then I show you a bit the challenges that you have when you have really large PV plants, and I'm talking about 700 megawatt that I had to observe the last 3 years. And I explain you a bit about the structure and the package that we developed to get these things done and to get all these enhancements. But the most interesting part, and you see it here also on the weight of the content slide, is just the samples to show how we did it really and what we achieved with the individual activities. Yes, that's me, and Stefano already talked about me. You see that I have about 25 years on software development, but I did during my software development also a main focus on renewable energies. And since 2005, I'm really totally in renewable energies. And now I want to start with the situation. The situation I already told you are 700 megawatt. That means about 3 million modules. That's a lot. It's a lot of size. It's a lot of cables. Just a number to get an idea for those who are not familiar with technical numbers. Only the module table border, that's the front line of all modules that we have mounted, and there are some in 1 row, some in 2 rows, even in 4 rows, is the distance of about 1700 kilometers. That's the distance from Hamburg to Rome. In other words, that means if you have to cut the grass in our assets, you have to walk from Hamburg to Rome. And when you're in Rome, the grass is already grown and you have to go back. Next one of the things is we have a lot of different local environments. There are different climates, there are different grid operators, there are different landscapes that makes it not equal, each parks, and some of our parks are even hard to arrive. To reach, you have to walk 5 hours. And last but not least, and this is one of the most important things, there are human aspects that you have to cross to pass through. Some of the numbers were just prepared to make the people know what they are dealing with and know what is the real impact. The target was just to operate all these parks with, in summary, the highest technical possible benefit. That means the technical possible benefit is the revenues reduced by the total O&M cost. So it doesn't make sense to over-service a park with a lot of costs. It means what is the difference between revenues and total O&M costs. And we do this as an owner advisor. Yeah. On the next slide, I have prepared to you to get all these tricky reports that we created and all these methodologies. I transformed it to a reference asset. A reference asset that I took is about a third, not even less than a third of the assets that I have really to watch, and it's 250 megawatt with a specific yield that's a result of 2014 that we have here of approximately 1,300, a bit more, a bit less. I put in a feed-in tariff for February 2015 of 25 euro cents. That's an average value I took. I could get from some of my friends who do the same on other parks, and it's some intermediate value. I took investment costs, real high investment costs of 2008 to 2010, for example, because the parks are not all new. And I took really high O&M costs, but they don't make too much troubles on the numbers. So I set in these really high costs and had also some external costs. And on this stage, I have to switch back to Stefano, because we have here a question prepared for you. Maybe I show the slide. Yeah. I want
yes,
to...
perfect, Gerhard. Go ahead, introduce the exercise, as you know it.
First the exercise. Thanks. What do you think is the additional return on a park, on capital, if you get only 1% higher energy production that you just skip from the losses that you have usually, that you reduce the external costs that are really small by some effects and 5%, and you get 3% reduction on the spare part stock. You will also see that it's nearly nothing. The main number is what do you think you get if you have 1% higher energy production on that reference portfolio of just 250 megawatt. And I think on the options, the colleague will help me.
Yes, exactly. So there are 4 options, as people can see. It's not the idea that you calculate right now, but it's an estimation. So we like to see how quickly you are in estimating the right number. Let's put up the poll. So based on what Gerhard mentioned, is the impact of this, the return on capital in 1 year, between 0 euros and 100,000, between 100,000 and 500,000. As you can see, option 3, 500,000 and 1 million, or more than 1 million, let's say up to 5 million euros in 1 year. Yeah, let's see what you guys think. Please share your thoughts. I think most people are already doing this. Some are trying to get their calculators out of their desk and still trying to get closer to it, but that's not the idea. I'm looking at my colleague. I think most of the people have almost voted. A couple more seconds, and let's see, Gerhard, what people think, and let's see if their estimate is right. I'm quite curious myself as well. Yeah, let's take a look at the results. Can you see them as well, Gerhard?
I cannot see them, but you will tell me.
I will tell you, indeed. So almost 10% of the people thinks this is lower than 100,000 euros in the first year.
Okay.
The vast part, 46% of the people thinks this is between 100,000 and 500,000. 25% almost thinks this is between 500,000 and 1 million. And the real optimist among us, 20% thinks this is more than over 1 million in 1 year. I'll hand over to you and let's see what, in your case, the real impact was.
Okay, thanks. Okay, what was the real impact? The real impact in this example was 800,000, more than 800,000 euro. And well, it's quite astonishing for most of us. And I think 25% is a good number who figured out it is more than 500,000. And it's more than 45% who figured out that is more than 500,000. Some are a bit too optimistic. First time I tried to set out also more than 5 million, but more than 5 million is not possible on Earth. You have to go there, for example, on the moon, then you have a better irradiation and not so many air losses. Let's continue. How do we get these numbers? You see here a financial model where all these numbers come from. It's you see on the right side the start conditions, and the most important part is the net sales. The net sales that you can achieve with such a park is about 80 million euros, and if you enhance them only by 1%, here you have it, then you get more than 800,000 euro higher revenues. And yes, for sure, if you have 1% or less losses, you can also reduce your external cost because not so many people have to come to the park and do troubleshooting. So we could reduce about 7 to 8%. Our external help, I set here down 5%, but it's not so much. You see, it's only 18,000 euro that you can get. And you see here also the colors. The colors in yellow are these parts that you can influence with O&M directly. And there are parts that you cannot influence with O&M. That's the cost on the asset because the parts are already fixed and already mounted, and it's not, and it's also the interest on capital because it's not part of a technician. You see the final result, return on capital, is about 833,000 euro, but it's only 0.1%. So 0.1% more enhancement on return on investment makes 800,000 euro. Now let's change from the financial part more to how you achieve it. Here I have a table with an overview of the parts that you can influence. You see here the economical factor performance, where performance is mainly you can take on finally on irradiation and model temperature. That are the two factors that give you main impact. And the third one is the technical quality, and the technical quality is that one that you can most control. And you see here in the product change, in the production change, that is possible by these different impacts. It's always 100% divided by number of strings, number of boxes, number of inverters, depends where you have your fault. So if you have a fault, if you have a breakdown, you're always 100% switched off, but divided by the structure, by the size of the structure. So if you have a lot of string, it is only a small portion. There are 2, 3 more, but not so huge impact components. The one is external help. You can reduce service on components. You can reduce cross-cutting prices. I will show you later in detail. You can a bit reduce your fixed cost, and you can also reduce your working capital by keeping the spare parts more or less. You can ask later if there are any questions, and you can, and we can now continue with the, now here it is.
Can I ask one question that comes in, Gerhard? Just in between. One of the attendees asked about the Albedo effects, which is on the previous slide or this slide. Can you elaborate briefly on that?
The Albedo effect is an effect that gives you some mirroring of the ground of the area that you have around the park, and can reduce your production down to 12% if there are some non-mirroring things around your park. and if there are mirroring things, or in best case, if there are snow fields, it will help you and get additional. But you can normally not, and you see here, there is nothing on the influence. You can normally not influence it during the O&M phase. You can influence it during the design, but it doesn't make really much, but it is to consider.
Okay. Thanks for explaining. Go ahead.
Now let's go in the other direction. Yeah. This slide shows the challenges that you have in huge parks. In different to small parks where you have your measuring instruments really near your models, here is the main thing, if you see it here, is to compare the power that you actually produce to the power that you should produce. And in large parks, it's really hard at every moment to know from every part the power that you should produce. Just you see the examples there. The energy is a function of the irradiation, the temperature, and the time. And to get the real the irradiation and the time, you have to consider that a park of 10 megawatts, that is a small portion of this 250 megawatt I'm talking here about, it had an area of 500 times 400 meters, and then cloud, it's a really fast cloud with 10 kilometers per hour. Normally clouds go a bit fast, slower than 10 kilometers per hour, lasts for 3 minutes only to cross this park. So that's a, you are, with your measurement, depending where your sensors are, you are 3 minutes away from real time. That is not a problem if you take the summary during a whole day, but it is a problem if you want to localize immediate faults that are not reported from the monitoring. The second is the effect of different cooling. You have a lot of different cooling situations. Wind, for example, on the upper rows and on the lower rows gives a different cooling, different mirroring, and here we are back to the Albedo effect. Far dark roads have higher temperature than not so dark roads, and the grass has other temperature, and on the border there are different wind circulations, and the large plate around the inverter platforms can enhance the temperature, can reduce it. We're talking only about differences of 2 or 3 degrees. And last but not least, if you have a lot of modules, and we're talking about 40 to 50,000 modules per 10 megawatt, you have 10 to 70 kilometers, depends on the arrangement of the modules, to watch them, to observe them, to double check them. So that are the challenges in large parks, and in order to get rid of them, to keep them under control, we developed a basic methodology and said, okay, it is not possible to do with the normally a situation like you have in the laboratory. You have your sensor, you have your clear conditions, but you have only approximately your conditions. So the only thing that you can compare is just take a thing, a technical thing, a string, an inverter, a combiner box, and compare it to the immediate neighbor or to a set of immediate neighbors and find out how the difference develops. So that helped us a lot to get much more nearer to the wanted results, and gives a lot of fine numbers. There are challenges to get this really perfect, but it's a really scientific discussion, and I think we should go on to how we put these things into our tools. On the tools you see here, we created a set of 3 different types of reports and checks. You see on the upper left side the performance reports. The performance reports are usual in most companies, and help you to get information if the park is working or if there's something dramatically raised up, away from the usual monitoring alarms on immediate breakdowns that are recorded by the monitoring system. After this, on next step, we have our technical standard checks that are not done in every week, every month, but also regularly. And we check, for example, inverter efficiency every 3 or 4 months. The sensors are checked in a special procedure, in a special schedule, depending on the weather situation, and so on. These standard checks help you to get control over faults that have about from 0.5 to 3 or 4% in worst case. And to go deeper, we have individual checks on suspects. If there is something working really bad or there are some suspects, there is some effect somewhere in this asset we have to achieve and to check it. There are also things that are more or less far away from technical, but helps you to get your partners who are working with you convinced what to do. For example, take these losses outside working hours. I take this example because it's really nice. We had a situation that we had standard O&M contracts, and the technicians, the parks are set up from so approximately 40 megawatt one unit, 30 to 80 megawatt one unit, with one service team located near the parks. And so it makes sense to have the technicians there. And we had standard O&M contracts, and that means working hours. So no Sunday, no Saturday, and from 9 to 5. In winter, the sun was coming out in one of the parks that I know at 9:30, so the first half hour nothing to do, and goes down at 4. And in summer, the sun comes out at 4 in the morning, and the operation team comes at 9, and then they drink coffee, and before 10, nothing happened. What we did is just to calculate all the losses that achieved during the time when no one was in the park, and put out this number on the table on discussion to change the working hours. And in the meantime, the contract is the guys have to be in the park when the sun is out. And it helped us about 0.5%, in summary, to have more or less losses. From technical point, and I will just continue on the next slide. From technical point, we developed a software system with a database to pick up the different monitoring system, because on large assets you don't have always the same structure. Sometimes we are glad to have over a wider range the same structure, but normally we have not. And we standardized this data from monitoring system and the part description. That means the structure, how are the strings combined, which model is on what position, how are they combined together, and put it in the PIT database. The PIT is standing for Performance Improvement Tools. And then we extract with really simple scripts. It's Java-based script. We extract our special tests to these reports. I've shown you the slide before. One short slide, what you need in addition. In addition, you need a well-organized team. You see here this team structure that we have. We have on the one hand the technical analysis team, that are guys more scientifical, who read all the effects that are possible in the literature, who are always on the conferences. We have the software development, and we have the O&M management of the daily business, and this team have to work together on starting with a suspect of the O&M management. I want to check out what is with the rain. Then how can we measure it? how could be the software solution. Then we test the first draft and get confirmation from the O&M management. Yes, that's what I expected, but can you just skip away this or generalize it? So we do it in 2 or 3 turns until we get to the tools. And I think the tools are the most interesting part. Here you see one tool that I shown already in history, I think last year it was there. We do not believe on performance ratio. That's some kind of philosophical thing, but it's also, we have this number of simulation against the really yield. So we do weather corrected simulation. What did you achieve from the park? What did you expect from the park? And what did the park really reach? And you see here one impact. That's the impact of snow in February 2014, where we had the effect that the green line, what should be, what was, sorry, that is the result, what we reached, and the red line, what would have been possible because of the sun and temperature situation. So that's the weather corrected yield again from the simulation. In normal phases, like you see here, it have to be equal or only small differences. And if you have a problem, then you have larger difference. The problem here is well known. But there are also cases on one day that you have problems anywhere, and then you have to go deeper. The next thing, sorry for scrolling in the wrong direction. The next thing is the effect of cleaning. The effect of cleaning and rain. In our parks, and the parks are located about 30 degrees plus minus. So you can take Italy, Spain as reference. We checked out that on the park where the models are tilted about 30 degree, 25, 30 degree, if you have more than 1 liter per square meter a minute, that's really heavy rain, or you have half this amount for 15 minutes at least, then you have the same effect from rain like you have from cleaning. That helps you a lot to reduce your costs. For example, we could skip out on about 200 megawatt of this 700 megawatt. We could skip a model cleaning, and that was a lot of money that we could leave. How did we do this? Really simple trick. What we're doing is just to observing the strings, comparing it, the principle I've shown before, and then we destroy this regular flow by cleaning some special modules, only one module of a string and of only one string of a combiner, and 300 meters away the next one. So we do 10, 12, 15, sometimes 20 strings that we clean on one day. The guys have to record it when was the cleaning date, and then we compare again, and here you see the effect of 0.5% of performance improvement of this string that was cleaned. So we know how dirty the modules are, and we had here a small rain, and the rain effect was not so much in this case. But doing this again and again and again during the 3 years, we find out that this magical value of 1 liter per square meter per minute that cleans your model really enough that you can skip the next cleaning. Observing the weather and observing the situation that makes your models dirty, that can also be, I know it from some parks in Sicily where the Sahara storm is a real impact on dirt. But observing this, what makes your model dirty and what makes your model clean, can optimize your schedule on model cleaning or skip it. A next effect is a really interesting one. It's the effect of forgotten grass cutting. Forgotten grass cutting was a nice story. I had some really nice guys who tried to tell me grass cutting is not so bad, we don't have so much impact. You see here one example on the picture, and you see here the lines, that's the collected local string losses of one inverter. That's always 4,000 strings, 4,000 modules. Up to 1%, this is normal fluctuation during a day. It's other local effects of some clouds that are not coming really fast over the parks. But all that is significant, about 1%, is an external input, is the input of this forgotten grass cutting. And here is the question. Here's the questions. How do I have to move over there? Yeah. What would be the losses in the whole reference portfolio of this 250 megawatt if the grass cutting is delayed for only 1 week? And I put you out here 4 options and ask Stefano to do the next poll.
Yes, thanks, Gerhard. Indeed, let's test the estimation skills of the audience one more time. So the question is, what will be the losses in this reference portfolio Gerhard has described if grass cutting is delayed or forgotten indeed for only 1 week? So in 1 week, the impact can be extra loss of up to 10,000 euros, between 10,000 and 50,000 euros, 50,000 and 100,000 euros. I'm amazed by these numbers actually, or even over 100,000 euros. So what is the impact of simple delaying of grass cutting? I want to invite everyone to give their estimation, and also remind you that you can ask questions to Gerhard just by writing them on the right hand side, and we'll be able to ask them straight away or afterwards, so please make use of that. I think let's wait a couple more seconds that most people now have voted for their estimation. Yes, let's take a look. Gerhard, I guess you cannot see it, so I'll just read it up.
Same game.
13% of the people that gave their estimation says it's below 10,000 euros. Almost 50% of the attendees says it's between 10,000 and 50,000 euros, the impact of 1 week delayed grass cutting. Almost 30% says this is between 50k and 100,000 euros. And 12%, the remaining percentage, says it's over 100,000 euros in 1 week. Yes, well, I'm curious. So show us what in your case was the impact.
Yeah, the impact is, thanks. The impact is, it was an increase of 3% within only 1 week, and here you see that they lost, they've forgotten four stations to clean. That was the western border, southwestern border of a park where you cannot see this corner if you enter the park only in the main building. And they tried to tell me everything is okay. Here we had losses of upcoming 3% within only 1 week. If you extrapolate it, you're in the range between 50 and 100,000, exactly between 45 and 90,000 euro, depends on how strong this week is from the weather situation. But if you take the season from May to September, it is near to 100,000 euro that you lose only on 1 week delay on grass cutting. So the right point for grass cutting is really a nice tool that helps you to go on and to keep the park under control.
Gerhard, one of the attendees said rightfully this depends on which part of the year it is. So this was for May to September. What would be roughly the loss if it was, let's say, in January or December?
In January or December, the grass is not growing in most of the regions where the parks are located. Okay. So grass starts upcoming. It depends. We have some areas more near tropical climate where the grass is not growing so fast, but it comes normally up April, May, and it stops growing in October, November. So between October and May, it is not really a problem.
Okay, fair enough. Thanks for elaborating.
Next tool that I want to show you, and that's for me the the highlight of the year 2015, because we had the problem that the guys in the parks had the philosophy: a fault that is not recorded is not a fault, because nobody knows. They didn't make this bill with me, because I was able to double check it on the monitoring system, and so we developed a tool to record all the losses on inverter and combining box level by comparing them to their neighbors. And we recorded every loss that is longer, with a longer impact than more than 20 minutes. That was our threshold, and maybe we can switch it down and reduce it. And on these losses, we had in 2013 4.5% losses on not really optimized service, on this combined on this effect that I told you before. Duty is only from Monday to Friday from 9 to 5, and if there is inverter breakdown on Friday afternoon, it will last till Tuesday, because Monday you cannot do anything, it's the first day in the week. It was a lot of education work, not so much technical work, but education work, and showing the guys on and on where they are located, where their parks are. You see, in the year 2014, most of the guys, most of the parks have checked it, but there are two green points, and I know very well which two these are, that had in April and June significant higher losses than the other ones. That was because of that kind of philosophy, and needed a change of the director of the technical guys in the park, and just repeating on and on where they are. We are now glad that we are in 2015 down to 0.2% of the production that is to write down to losses that we reach on missing inverter, so that inverter stop, inverter not running, not at full capacity, is down to below 0.2%. So we had 4.3% less on this only fault. It's only the fault on inverter. I don't make it a third poll, because I wrote down the number for this 250 megawatt, and that's about 3.2 million. And I think if you have some kind of bonus scheme for doing O&M supervision for those guys who are glad to do this job, you should ask about 50% of this as bonus for you, though. Then you have not so many problems to finance your team. On the next slide, there is a tool that was originally created to locate bad strings. It's we had the problem 2,000 modules of a bad production where these are distributed somewhere in the park, and you have to find out the strings. You have to check it out where they are, and the only thing to get these bad models is take an infrared picture from the back side of the module, so that you cannot do it with the helicopter. And the park was about 160,000 models, and here we could just find out the bad models by this tool. You see here one cell for each string in the whole park. The interesting thing was some additional knowledge about the park, the difference between little wind and strong wind. You see on the upper part here a clear structure, two lines with numbers about 100% and two lines with 1 and 1.5% less than the neighbor strings. That is caused on a day that was windy more than 10 meters per second, or 36 kilometers per hour, and it is the cooling effect on the upper row against the lower row. Another nice thing, and I've fit in a picture, was a park where half of the park was flooded because a rice field on the right side was going over, and the water swept into the park, and we were really bad about, we were really sad. And, but then we did a calculation, and I did also the location of bed string test, and then we could find out that you see here these yellow numbers, and you see the green numbers, and that shows that you have higher performance in this kind of the park than in this kind of in this part of the park. And we had about 1.5 higher performance caused by the cooling effect of the evaporation of the water for a week or two. A nice effect and really astonishing. Yeah, that's for this tool, location of bed string, and also understanding your part on structural effects. This is more or less one of my last slides. It's just to show what would happen if you stop O&M service. Here we have the bad situation of an asset that is in a region where voice and caused by water, technician are not able to service this park, or were not able to service this park anymore. And we got only no monitoring contact to the parks, and it is only possible on phone calls to some guys who are still there to get the numbers of inverters that are not running. And based on the numbers that we had from the last 3 years of these parks, we could estimate the losses that are now coming up because of inverters that are not running. And here's a dramatic increase of 751% from April to August 2015. That is still under a level that is visible under the usual records that you have normal for management, just a yield report, how much was production, how much was the budget, and if the weather was fine, the difference of the weather correcting all the budget. This is just reduced to the losses. And you see another effect that is really astonishing. You see here the effect of one inverter. On the blue boxes you see how many inverter days we have lost because there was one inverter standing a whole year. And on the brown bars you see how many kilowatt hours were lost due to this bad inverter in these parks. And you see that there is a reason, the same like on grass cutting, that November till February the losses are really low. Also, one inverter is really not running. And you see on the other side that during the main reason in this specific park, it is July, August, the losses are really high. I will come to my, from point of view, to my last slide, where you see here this situation on 10 parks, and you see really clear on the one side how many inverter days we have lost. You see the upcoming one inverter is standing here. Here are two more, so we have next month 3 inverter days per day, and there is the next one coming. You see here it was okay more or less, but then 2 inverters broke down. Here is 1 coming up, so it's getting worse and worse. But the effect on the kilowatt hours that you see in normal monitoring report only occurs in seasons of high production. You see here only from March on significant values. Also, the inverter was standing. During the winter season, it was not to recognize that there is something wrong with the park. So at the moment we are more or less happy that we know what is coming up in April, what will come up in March, April, and we have still a few months to correct this. And yeah, I hope the guys will do this. The message here, and that's the conclusion of what I've presented you in the last hour, is a reduction of 4 to 5% from total production is possible, even if the parks are really state-of-the-art technical, but only from operational point of view and taking care of a lot of 0.1% that you can do. But if you stop observing your park and stop knowing what is going on, you will waste this effect within 6 months immediately after you stop your O&M service. So that was technical. My last slide. There is still one more slide. That's usual. That's the thanks for the attendees, for the attention. And I'm open now for some questions. Stefano, you can collect.
Yes, Gerhard, thanks a lot for presenting, for your transparency. You can tell it's not always easy to get people sharing in this way, and we do have a bunch of questions for you, so we can't let you go yet. Can we go just 2 slides back? I believe it's to the slide with the water and the bad panels. Well, I'll just read up the questions. Let's try to address all of them in a concise way. Because of time, of course.
Mm-hmm.
Okay. One question is very to the point, I think. Can you detect bad panels while using only string data? Or what do you need additional?
No, we cannot detect bad panels by using string data, but we can localize it down to the string. So it means normally in these parks there was 22 models in one string. So what we can do is just to find out in which string there is a problem. But if you have to check out 160,000 models, you have a lot to do. And if you have to go to 20 models, you know it within 10 minutes, which one of the models is the real bad one. Most of the time, when we do this every 3 months, and there are special situations like grass cutting with the trimmer where they throw stones on the models and you have a lot of impact. It is clear visible what the fault is. It is clear visible you have a burnt plug that is not burned so much that is connected, unconnected totally. You have broken glasses, for example, from a stone that was thrown against the model. So in most of the times you see it really clear what the reason is. In the other case with the bypass diodes, that was the reason to develop this tool. You have then to check with the infrared camera 20 models, but it is much less than 160,000. Next question.
Thanks, Gerhard. Thanks, Gerhard. Additional to this, a question is, do you rely, your data is quite intensive, do you rely on data directly from the inverters, or do you add additional sensors to get sufficient data points for your analysis?
We take for the analysis the values from the monitoring system and double check the consistency of the data, because the most common fault is just not connected to monitoring system. So usually we take, for example, we take the values of the strings and compare it to the value of the combining box that's also recorded in the monitoring system. And if there is any deviation, then we can assume that it is only a fault on not recorded, but we check it immediately. The same is on the next level. We take the summary of all strings, we take the summary of all combining boxes and double check it with the inverter. And if these numbers differ too much, because there are some causes where there can be differences, but if they differ too much, then we double check again, can we trust this number, can we not trust? That is one of the problems. Thanks for the question. That is one of the challenges that you have. First, you have to avoid that you are blinded by the numbers that you get presented, because first thing is don't trust the numbers you get, just prove the numbers and then send them into the tools. Next one.
Yes, additional to that, what do you think about typical monitoring specification of PV plants as delivered by typical EPCs, from your experience, of course?
We are just on a step at the moment to find out how far we can go if we don't have total information. In the parks that we observe, we take always monitoring down to string level, at least string level that is done by inverter when 4 or 5 strings are on one MPP tracker, for example, on string inverters. But we go down as deep as we can, and it's nice if you have values on string level. It helps you a lot, especially on localizing bad models, especially on localizing faults, especially on comparing regions of parks against neighbor regions to detect things that occur, for example, fast degradation, like we know some producer of models that have the problem with thin film models. When they break down, you can detect them when you have it on string level, but you have not really a chance, then, because then you have to check 400 modules and not 20 modules. So the resolution should be down to string level. It doesn't make sense to go down to module level, because a portion of 20 modules is absolutely enough. I know that there are some also some figures going down to module level that makes only sense on private units, but not if you have 3 million modules like we have. It's not to handle from the data. So downstream level is a good compromise. It should be.
Okay, thanks for sharing your thoughts on that, Gerhard. Still on this slide, I think the question is, clearly is, could the water have an albedo effect rather than evaporative cooling, what you mentioned? What are your thoughts on that?
Yeah, it has, but I didn't measure it. We had a lot of other troubles here to keep the park alive, because the positive effect is here just yeah, to point out and show, do not expect that everything is bad. We had a lot of troubles with the cables. We had a lot of troubles with the combining boxes. We had a lot of trouble with flooded cable channels, and we are glad that nothing really bad happened there. So I do not recommend to flood the parks if they are not designed for being underwater.
Okay.
The albedo effect is clear because there's a mirroring on the surface, but this mirroring is only is more when the wind is not coming, is not blowing, because then you have the waves that. So I didn't take the time to measure it, but it is.
Okay, fair enough. A couple of questions related to, I believe, your previous slide on inverter faults. Can you go there?
Inverter faults, you mean that slide here?
No, back still. I guess this one. Let me see. First question, in case of faults, do you have a centralized warehouse, or do you have spare parts available closer to the parks? How do you work with this? Can you explain briefly?
We have a mixture. We have a central warehouse to be able to bring expensive spare parts, like larger portions of central inverters to the location where is needed. And we have local spare parts for things that regularly happen. For example, fuses on strings, because the string fuse is going in every park every day. So spare parts that are needed in daily business, because it is daily business, we have immediately in the parks or near the parks, or at least one container within half an hour to the park. And really expensive spare parts that can be used in different parks are centralized and are distributed by tricky logistics system on the technician who make on the specialists who are traveling around. It's also, we split up the monitoring team on guys who can do daily work like changing the fuse or reconnecting the cable, And on the other hand, we have specialists who are able to set up a central inverter totally new and renew it. That doesn't happen every day. So the specialist is always traveling to the parks, and the daily business like taking care of cutting grass, changing plugs, changing fuses, that are guys at not so high education level, but we just try to set up this education level that they can do more and more that are in the parks. And according to this, also the spare parts are organized.
Okay. Can we go to slide 21?
This is here.
Yes. Let me see the question. What types of faults are we talking about here, and which were the 2 or 3 major faults? Can you elaborate on that?
Here we had faults on inverter is not switching on and should start. He lost his memory, he lost starting in the morning. It doesn't remember, nobody switched it on. It was in the first year of the problems. And in 2014, we had a lot of problems of unserviced Q4 and Q6 switches, the power switches in the inverter, and they were not serviced well, and during some switch state they broke down or they got inverter stop. Most of the time it's possible to just restart the inverter and go up again and change during the week the switches. Some guys were really specialists in nothing. It was just, if you cannot handle, just inform the inverter service company or the inverter company, and they recorded 5 days after the breakdown, recorded by then. Inverter company is informed, and that's why we get sometimes really dramatic high losses because inverters were staying for days. There was one fault I can remember. We have a master slave was always 2 inverter are switched to the same field, and up to 50%. One inverter is taking the whole load, and the other one coming later then. And this master slave switching wasn't really well programmed. There were some software situations, where the software couldn't handle it really, and so the slave inverter didn't come up. That's also the thing that we changed on talking with the Inverter Effect, inverter company, inverter service company, and we sensibilized our team so that they took care, as long as the software was not updated, and with the software updated, we had some problems. A lot of small problems on inverter level are there's only one phase, it's not running really an MPP tracker, but that are single faults that happen, and the only thing to reduce the total amount is a fast reaction.
Okay.
Regular faults, yeah.
Can you move a bit closer to the mic, by the way, because the sound before was a bit better. We'll shoot one last question, but I have to say the questions are coming in, so we'll try to share that afterwards, and also a lot of compliments for a very interesting presentation. Let me see here, which one can I pick? During the inverter standard warranty period, do you ask only for standard reparation works in case of failure, or did you use some additional agreements with the inverter manufacturer to improve the service, response time, etc.?
Okay. In the meantime, these parks are out of the 2 years standard warranty. I'm not sure in 2013 if there was something. Yes, there were 2 or 3 parks were in the standard warranty. We had during the standard warranty no special agreement with the inverter producers, but we keep them really on track. So we organize them like part of our own team and have really close contact to them. That is usual because of huge assets, and we have only 2 or 3, 4, and only a handful of inverter producers, so it wasn't to spread up too much. So it was easy to handle a few service teams and discuss with them the enhancement, and they were really interested to work together because they got input from us that they normally not could get on users that have only one inverter, because I know one inverter where we have 1,000 pieces. So that's a huge amount of inverter of similar types, and it was very interesting for the inverter company working together with us, and so it was not necessary to have a special contract.
Okay, fair enough, Gerhard. Thanks for again. Thanks for sharing with us. I know you have to run yourself, so let's round off here. We will see you back in 3 weeks at the conference Solar Asset Management Europe. So people will meet you there. You'll be presenting as well. We look forward to having you there again. I want to remind people that didn't read this earlier about the discount code they can use in case they didn't register yet for the conference. They're planning to. Gerhard and the attendees, thanks very much for joining us. We will provide you with the slides and the recordings afterwards, so we can hopefully connect you and answer the questions out there. Look forward to see you at one of our upcoming events around the world, and I wish you all a great day for the rest. Bye-bye.
Goodbye.